Hey, what's up everybody? So, for the video for today, I want to test materials. Materials that are commonly used in, or as an dielectricum in DIY capacitors. So, yes, I built a high voltage capacitor in one of my previous videos, and I tried a little bit around with the dielectrical material. So in this case I used some, how is this? I write it down for you to get it right on English. Some page protector film, that's this here. And yeah, in this video I tested it a little bit on the high voltage and wanted to see if it breaks down at around 4 kilovolts, and yeah, it didn't. So now I got really curious, how strong is this material? What's the voltage this material breaks down and the arc getting through, and the capacitor will burn down. So I have many more. I have here some polypropylene. There I have some way thinner polypropylene film. I have baking paper, some of this super thin wrap foil or cling foil. I have some glass. It's around 1 millimeter thick. But for the thickness, we come later to this. I measured these all materials for the thickness. I also want to test some paper. This is really thin, just normal paper. And there we have some drawing paper. It's a little bit thicker. And I want to test this just dry. I think this voltage rating will be really bad. And for the second test, I want to test this with paraffin oil. And yeah, I wonder how strong this paper gets when I get some oil on it. So for this, I build up some test equipment that I want to show you first. Yeah, let's start this. So for the high voltage transformers, for the around 2300 volts, I'm using my big thrusty microwave oven transformer. So when this voltage is not enough to break through the dielectric material, I will use the voltage doubler. So I'm getting around 4600 volts. Actually the high voltage peaks will get a little bit higher, but I'm not sure about this, how high this will get. So for the second high voltage transformer, I'm using an old oil burner starter transformer or start transformer. This transformer has an output of around 7.5 kilovolts at 23 milliamps. So when these 7.5 kilovolts or peak kilovolts about 11, when this is not enough, I built a voltage doubler. This actually works not that good, but we don't need much power. So this capacitor bank is really small, so this arc has not much power in it, but the voltage will be really high. I tested it, and yeah, these arcs igniting at around 2.5 centimeters away from the poles. So I think I'm getting around 20 kilovolts. So I think this will be enough to break down anything, everything, but not the glass. So I'm curious about this, But I think this glass will withstand 20 kilovolts easily. But yeah, when you have an idea, or you have an idea how high this voltage rating of these materials will be, you can write it down in the comments, and yeah, see later if you're getting right. So for the test capacitor, I will build every time. I'm using some copper sheets. I insulate this through this clear glass. I will lay down a copper sheet, pack on it like something like this glass. And for the other pole, I'm using the other copper sheet. And yeah, in this case, we have a capacitor. So I will press this down with some screws, trying to get a little bit pressure on it. And then I will measure the capacitance of this capacitor. And after this, I will apply first the 2.3 kilovolts from the microwave oven transformer without the voltage doubler, then the 4.6 kilovolts with the voltage doubler. So keep in mind the voltage peaks are getting a little bit higher, so probably it's about, with the voltage doubler, about 5 to 6 kilovolts, but I don't really know actually. And yeah, when this is being strong, I'm using the starter transformer. Try it first with the 7.5 kilovolts or 11 kilovolts peak, and when I didn't burn through the material, I'm using the voltage doubler. But me personally, I think I don't need the voltage doubler. This voltage peaks are really serious. I don't think that any material, not the glass, that any of this material will withstand 11 kilovolts peak. But yeah, we are here to find this out. And I would say we just start at first with the drawing paper. At first, just dry, or as dry I get it here, just on the normal air. And I think this will break through really fast, and then I will try it with the paraffin oil, and let's see what will change in capacitance and in the voltage rating. So let's start the fun. So there we have the finished capacitor. When we look at the datas, the drawing paper has a thickness of about 0.1 millimeters. Yeah, so now let's just measure the capacitance. It's 0.88 or 89 nanofarad. Okay, so we can write this down, because later we will test it with the paraffin oil to test if the capacitance goes a little bit up, or maybe goes a little bit down. But I think we get a little bit more capacitance out of the paper when we soak it in oil. But yeah, so at first I would say we try this with the 2 kilovolts. B plus is on the capacitor, and in my hand or on my tube I have the ground wire. So let's just test it if the capacitor breaks down. Yeah, instantly. This capacitor is already dead. Okay. Okay, let's see what's happening here. You see, before I touched it, we have here a burning hole through the insulating paper. And yeah, nothing spectacular. It just burns a hole through this. You can see it a little bit. Focus on the copper plate, also on this copper plate, but it's not deep, it's not bad. Feel nothing. Okay, now let's try it with the oil. Now I soaked the paper in oil, in paraffin oil, and now I want to measure the capacitance of this capacitor. Wow, okay, that's a big difference to the previous test without the oil. On the previous test we had on the exact same paper, we had 0.8 nanofarad, I think. And now we have 2.8. So that's a big difference. Yeah, now I'm really stoked about to test this out on the 2 kilovolts. And yeah, let's see what happens. Something happens. But I see nothing. I didn't see something burning, whatever. Just let's wait. Man, there's some current going on. Is this oil conducting? Or conductive? That would be really crazy. So I don't know if you can hear this. So this transformer has to work. Ah yeah, now I see it. There are sometimes some little arcs. Okay, let's just switch this off and let's look what happens. Because I'm a little bit curious what's going on here. I just want to measure the resistance of this capacitor. So I'm not really sure about that, but yeah, we have no conducting. So this, oh, I didn't measure it right. Okay, 2.6 mega ohms. So, oops, there can be two things are going on. One, the oil somehow conducts, but nah, I don't think this is possible. And the second one is just because there were some super little arcs between the both of the plates through the dielectric. There is some carbonating going on between the plates, and now I measure this. So in this case I built a little resistor. Okay, let's just ensemble this capacitor and let's look what's going on with the paper. Okay, Let's see what's going on here. Oops. Okay. These plates are still a little bit warm, so some energy was going on here. Yeah, it clearly burned through the dielectric material or the paper sheet. Yeah, so because of this, I would say I have a second or different paper. Paper, and this is even thinner, but I'm honest, I just don't have to test this because this will result in exactly the same thing. So yeah, I would say let's just move on with the plastic films, with the polypropylene and baking paper and so on. Yeah, just to notice this oh, my pen. Yeah, this didn't work for my applications. So when you're interested of it, how strong this paper will go, I have different transformers and different voltage ratings from about 200 volts up to 600 volts, and then I can go a little bit higher or double the voltage with a voltage doubler, so to get it even higher to 1.2 kilovolts. So when enough of you guys write this down in the comments that you want to see more tests with the paper soaked in oil, or I just now have the paraffin oil, but when you want to see more about this, I can do an extra video about this. But in this video I just want to test some dielectric for high voltage capacitors. So for my use on my Tesla coil, I need a voltage rating at least 4 kilovolts. So better is to get a little bit more. So because of this, I just don't use paper for now. Yeah, I think this will be the same thing with the baking paper, but yeah, I would say let's try it. There we have the baking paper. Now I want to measure the capacity. Oh, that looks bad. What the heck? That's not much. I push it down a little bit more. But nah, that's not getting better. Okay, the baking paper is really bad. Okay, let's just try it out with 2 kilovolts and look if it breaks down. But yeah, I think this stuff is really bad. Yeah. Yeah, you can hear it clearly. This is arcing internally, instantly. So for this voltage, no way. For less voltage, yeah, okay, you can use baking paper, that's just okay. But and also paper, but at 2 kilovolts, nah, no way. Okay, just let's take a look how this looks. Yeah, just easily burn through it, no problem. Yeah, copper plate got a little bit. I think I have to polish it a little bit before I starting with the plastic films. Okay. Dun dun dun. Okay. Baking paper is out of the game. So the next one is the book cover film. The 0.05 millimeter thickness. It's polypropylene, and I already tested it because I have here this blue capacitor built out of this foil. So at least 4 kilovolts. Yeah, it can withstand 4 kilovolts. I'm really sure about this. But yeah, let's test it to the limit. Now I cut out a piece of this book cover film. That's polypropylene film. That's the thicker one with the 0.05 millimeter thickness. Yeah, and let's try how this works. Okay, let's measure it first for the capacity. Oh, 0.79, almost 0.8. That's cool. That's okay. It's almost like the paper without the oil. Okay, now I'm really stoked about to test this out. Where are the limits on this super thin? I don't know if you can see this foil. Probably not. How good this foil works. Yes. Okay, let's apply some 2 kilovolts to this capacitor. Yeah, it's holding strong. That's cool. The cool thing about this is, look at this aluminum foil. How this gets attracted to the ground wire. So now we're using the voltage doubler circuit, the capacitor and the microwave oven diode to double the voltage to around, I think 5 kilovolt peak or 6 kilovolt peak maybe, because it's not under load. Funny thing, when I switch it on, the aluminum foil moves. Okay, let's see if this capacitor breaks down. No, it didn't. That's cool. So when you look at the normal arcs from the voltage doubler, look like this. And this is just through the capacitor. That's actually crazy. That's a really high voltage at this 0.05 millimeter foil, or film, sorry. And when I just load this thing down, will it break through? I don't know. Yeah, nice. I would say we need the higher voltage to kill this capacitor. So I hooked up the oil burner ignition transformer, and like you can see probably, something has changed. So because that's actually not my first try. Yeah, I just want to blend in a part of this video instantly. What the heck? So, like you have seen, the voltage was tremendously higher. I don't know what's going on there. Yes, the voltage doubler was applied to the transformer, but I didn't use it like it. But something happened, and the voltage was so high that the arcs jumped all the way from one point to the plate, so from the screw to the plate, and that's actually about, yeah, I think 2.5 or 3 centimeters. So in this case, 11 kilowatt peak won't do this, I think. So yeah, it's probably way higher. So in this case, I just hooked up my rod to the earth or to the ground, and just using one coil first. That should have 3.75 kilovolt, but the peak voltage will be much higher. I actually don't know how high this is, but when we draw some arcs, I'll just switch this on, we can actually see the distance. We do it here, you can see it better. These are about, I think, 5 millimeters. I think these are about 5 kilovolts. Or more, maybe. I don't know. So let's try it just like it is now and move on with higher voltage later to kill this capacitor. Okay, I would say this will work. It's not breaking through. So, okay, let's hook up the second coil and double the voltage of this transformer. So I hooked up the second coil of the transformer. These are two secondaries, now they are in series, and this transformer should produce about 11 kilovolts, but I think that's a little bit higher. But yeah, let's see. Just turn this on and look at that, how spicy this is. Huh. But I have the feeling is this capacitor dead? Okay, the moment of truth. Whoops. Okay, that's different. It just burned in the middle. Okay, we killed the foil. Wow. So in this case we know 11 kilovolts or maybe a little bit more are enough to kill this foil, but about 5.5 kilovolts peak don't kill this. So our voltage rating is at least 5.5 kilovolts with this foil. Now I built this capacitor with the super thin polypropylene film, and it's actually 0.02 millimeters thick. So before we had the polypropylene film with 0.05 millimeters. So this is an interesting comparison, because when I write with the film from before with about 5.5 kilovolts safely, we should manage to get about a voltage of 2 kilovolts or a little bit over 2 kilovolts on this capacitor now without breakdown. And then I want to test it with 4 kilovolts or just the microwave oven transformer with the voltage doubler. And yeah, it's really interesting what happened. Yeah, let's measure the capacity of this thing. Yeah, 1.45 nanofarad. Funny thing is, we had 790 picofarads before, on a little bit more than the half of the thickness. Now double of the thickness. Now we have about the half of the thickness and about the double of the capacity. So that's a nice indicator. Okay, let's test this. 2.3 kilovolts. Okay, let's go. Oh. And it's dead. That's interesting. Okay, it's on the edge. The foil is sticking, or the film is sticking on the copper sheet. Burned instantly through it. Didn't see it. Okay. That's bad. Okay. Dum. So now we have here a capacitor with the polyethylene film out of some page protector. So that's just one layer of it. So, and this one layer has a thickness of about 0.06 millimeters. Okay, now let's test the capacity. Almost, yeah, 0.7 nanofarad. Okay, it's a little bit less like the polypropylene film, but the polypropylene is also a little bit thinner. So yeah, that's an interesting data. Okay, just let's test this out. So 2 or 2.3 kilovolts. No, everything is fine. Okay, about 5 kilovolts over the voltage doubler. Funny thing is happening here. If you see this foil vibrating, that's cool. Okay. This looks like, yeah, the foil just died. Okay, that's an interesting data. That says, just have to shorten everything out. That says that the polyethylene film, even if it's thicker than the polypropylene film, the polyethylene film is thicker than the polypropylene film. The polyethylene film will break down sooner on the, I think, about 5 kilovolt over the voltage doubler. So in this case, I actually know that's what I'm using here on this big capacitor. I've done everything right with this, because when you have seen the video about this capacitor, I was struggling to yeah, I thought when I use just one layer of the foil I can double the capacity, but it's really risky. And later I decided to use double layer. So in this case, when I had just used one layer on this capacitor, maybe this will work for a while, but it yeah, sooner or later will break down and destroy itself. And yeah, for this much work, this would be really bad. Okay, I've done everything right on this. Yeah, good to know. Let's take a look what's going on here. Ah, okay. Yeah, it's on the edge again, like almost every time. So this time it's here on the edge. The last time with the really thin polypropylene film, it was about on this edge, and before with the only thing with the thicker polypropylene film, it was in the middle. But I think maybe there was a little, I don't know, some dust or something that pushed into the foil, or maybe a failing of the foil itself from production. I don't know actually, but yeah, mostly it's on the edge. So before with the paper it was somewhere here on the edges. Yeah, that's because of the a little bit sharp edges. And now we have our last plastic film, the polyethylene cling film or wrapping film. That's the super thin plastic film you wrap sometimes your bread into it. Yeah, I read about many people using this to build some DIY capacitors, and I see, yes, it has a really high capacity because this film is really thin. I think that's almost not worth it to test it with the microwave oven transformer then, because I think this break down easily on 2 kilovolts without problems. But yeah, anyway, we are here to test this too. Okay, here we go. 2 kilovolts. Yeah. Almost instantly. Okay, let's take a look what happened. Oh, it's just a teeny tiny hole here in the foil, not even right on the edge. Is there another one? Oh yeah. Oh, I think this foil actually has some holes, because two on the two different spots. That's strange. Okay, but yeah, this film is less than 0.01 millimeter thick, so that's okay. Can say something about this. So for myself, I would recommend to build a capacitor out of this. Don't even a low voltage capacitor. Maybe for, I don't know, 10 or 12 volts it's okay, but not higher than this, because this is so thin. No way this getting produced really good without some production failures. Yeah, maybe you find a little bit thicker one that's a little bit stronger, and the failing rate is a little bit lower, but no way. And the last one is the glass plate. I actually don't know what type of glass this is, but it's 1 millimeter thick, and yeah, actually I think this is so extremely high in the voltage rating that I don't being able to break this. Also because this glass plate is a little bit small, so I think the arcs, so this capacitor will arc internally between the plates but not through this glass, because the arc will find a shorter way. Okay, we have just about 300 picofarad or 0.3 nanofarad. Yeah, the glass plate is the thickest of the materials we tested here, and also glass is not the best dielectricum, I think. I'm not sure, no. Yeah, but anyway, let's test this. But I think I just apply this one. I think this makes no sense to test this with a microwave oven transformer. So first test just with 1/2 of the secondary applied. This will make I think about 5.5 to 6 kilovolts. So it's a little bit more than the single microwave oven transformer with the voltage doubler. So let's see what happens. Yeah, just works great. So absolutely no problem here. Okay, now let's double the voltage. So the second half of the secondary is applied. We have now about 11 kilovolts. I think it's more of voltage here. Yeah, I would say easy without problems. Can you hear this? Okay, let's use the voltage doubler. Okay, voltage doubler is installed. Just let's fire this thing up. Man. Oh yeah. This whole capacitor will arc internally. Wait, I switched the light off for you guys. Oh, you can see the corona discharge before the arc strikes, when you see closely. That's crazy. That's fun. Okay, but what did we learn about out of this super long video? Yeah, for me, for my thing, what I still want to build a bigger capacitor for the voltage doubler circuit on this Tesla coil. I now know I can't use all these things. So I thought about using paper or using some thinner polypropylene film to build a little bit smaller capacitor or a big capacitor but with a really high capacity. Yeah, or maybe using glass or whatever. But in this case, yeah, I can be sure this don't work out because glass, I can't roll glass into an capacitor, and also it has at this thickness and really low capacity. Yeah, about the paper, I thought this will work up to 2 kilovolts, but doesn't. I think when we use a little bit thicker paper and soak it with oil, this will work. But yeah, in this case, or in my scenario now, this doesn't work. Yeah, so the only thing that I have is here polypropylene film for the book cover thing. With an okay capacity and yeah, good voltage rating. I'm still not sure how far I can get with this, but 5.5 kilovolts or about 5.5 kilovolts is really okay, and I really know that this capacitor is strong enough to yeah, work as a voltage doubler capacitor in my Tesla coil. And yeah, maybe you onto something similar, and yeah, now you have a little list how these things work. Yeah, when you're interested in that I test all this what break through in this test with lower voltages, maybe 200 up to 1000 volt. Yeah, write this down in the comments, and when enough of you guys interested in this, I will test this too on lower voltages, especially the paper. This is interesting, I think, because can build nice capacitors out of that. Like many years ago, this was a thing actually on DIY capacitors. So paper oil capacitors. Yeah. Okay, I would say that's all from me today. Man, what a mess. This video is super long. Sorry for this. Yeah, I would say have a nice evening, have a nice day, nice morning, whatever. Stay safe, have fun. Bye bye.